I thought I might have tried to talk something completely different. But we've heard a lot today about materials. We've heard in the last talk about the future materials that may want to feed into things. We've heard about packaging and need for materials. And I think we've heard about new materials in terms of circular economy. And so it seemed natural I should finish by talking a little bit about the Royce Institute, because the Royce Institute was established to develop and capitalise on the UK's world-leading excellence in advanced materials research. And if you look at the 5 areas they're working on, which are listed down the left-hand side, it seems extremely applicable to the semiconductor work we've been hearing about today, since I think we can fit semiconductors in all 5 of the things on the left-hand side, which Royce is working on. So Royce is gathered to try and bring industry, universities, RTOs together to work together on materials problems and their translation. And it's set up as having a hub and spoke model. There's a hub in the University of Manchester, in the Royce building in the University of Manchester, and a set of partners around the UK which are listed here. And you'll find of University of Leeds is one of those partners. Now, one thing I want to stress at this point is though the Royce Institute was set up with a hub and a set of partners, it is for the UK materials research, and those partners in the hub are meant to be delivering for the UK. It is not just that set of partners. So please look at what people are doing and the partnership, but we're trying to work for the UK. So the Royce divides itself into a number of research areas, and these are listed here. The one that is particularly relevant I'm going to talk about is atoms devices, which I co-lead with my partners in crime at Imperial, Cambridge and Manchester. And these are the people who have been working on the theme up to now. There have been some changes just happening with a couple of those research areas just being replaced, and you'll see that on the website very shortly. So atoms device is very relevant, and of course the 2D materials theme is very relevant as well to the semiconductor picture. And what I'd like to do today is to look at the atoms devices theme and think about how we might have aligned some of the activities in Royce with what is happening in the semiconductor strategy, which is coming recently. So Royce is wanting to deliver across those areas you've seen advanced materials and their translation, and it has 4 sort of mission pillars here. The first one at the top is enabling national materials foresighting and looking at collaboration and strategy. The second one is, in no particular order, catalysing industrial collaboration and exploitation of materials research. There's then providing access to latest facilities and capability. And then the other one we've heard a lot about today is the skills piece and fostering material science skills development. And I want to just go through each of those in turn very briefly and say some of the things that are happening just to give you a flavour of what the Royce has been doing. So if we look at materials foresighting, we've been doing some of these activities for a while now. And this started in May 2019. Response, it seems a long while ago now, to the report on net zero, for the parliamentary report, and what we needed to get to net zero by 2050. And it was apparent immediately that, as we've been hearing today, electronic devices is quite a challenge to get to our net zero targets. And we divided this into a number of areas: materials for photovoltaics, low carbon methods of hydrogen generation. We then had thermoelectrics and calorics, and materials for lower loss electronics or high efficiency electronics, whichever way you want to put that. And we set about a set of roadmaps. This was all going to be in person, but unfortunately COVID hit, so it's all online. But this was then published in September 2020, and do have a look at that. And it involved a consultation with a large number of both academic, industrial organisations across the UK. And the launch, we had 500 online delegates, roughly, and about 170 participants in the workshop. So that was what happened in terms of trying to put those roadmaps together, and it's worth having a look at them. But with 4 different areas, which were led by different institutions, But interestingly, if you look at those 4 different areas, whether you're working on photovoltaics, or you're working on electronics, or you're working on low-carbon methods of hydrogen generation, there were some common themes that came out, and I think it's worth just looking at these. These are the things that came out across those themes as being important, and I think they have a lot of synergy with things we've been hearing today. I think infrastructure from lab to prototype devices and towards manufacture. Perhaps we've had less about today some of the metrology aspects, which I think are very important as we go forward. National coordination between academia and industry. And I think the 2 towards the bottom, the low-carbon technologies and materials which are abundant, scalable and recyclable, are still going to be very relevant and mean the materials are going to be very important as we go forward for the next few years, but also going forward to 2030, 2040, 2050. So these topics emerge from that set of roadmaps and I think align very well with what we've heard a lot about today. So if we just consider one of those, we'll look at the low-loss electronics package, which is closely aligned, and looking at materials aspects for this. There were really 3 sets of material families we looked at. Materials for power electronics, we've heard plenty about that. Materials for CMOS, and what we really meant it here was the integration with CMOS. And the materials for beyond CMOS architectures, for things like the spintronic devices, the neuromorphic computing, these kind of materials which will be future solutions, but probably aren't the solutions as yet. And again, you can see a reference there and look on the Royce website and you will find that. So having done this work, doing some road mapping, we were pleased when the semiconductor infrastructure study launched, and actually, again, there was a lot of things that look very common between these 2. And this was launched in, a year and a bit ago now, 2 years ago, in fact. And we were part of this IFM study. Charles already mentioned that. So the University of Leeds, University of Leeds, Cambridge and Imperial were part of that IFM team. And of course, during that, the semiconductor strategy also emerged. The IFM study had started before that happened. So I think there's a connection between some of the things we've been doing with Royce early on in materials for the energy transition, and we can see that feeding in some of the infrastructure study and the semiconductor strategy as it emerged. So let me move on then to the second part of that, which is, and now you're going to see it in 2 halves. This is the Royce Zone, provide access to latest facilities and capability. Semiconductor strategy, we see generate breakthroughs and innovations that will drive next generation's semiconductors. So there's a lot of facilities within the Royce Institute which are open access facilities, and please do come and talk to us about accessing them. I'm just going to pick a couple out now. Might do. So on the left-hand side, the massive stainless steel on the left-hand side there is a multi-deposition chamber system at the University of Leeds, which was funded by Royce. It combines sputtered metal oxide thin films with the PLD, that's plasma laser deposition of complex oxides, MBE growth of particularly topological materials, and thermal evaporations of organics, all within one combined UHV system. So this is designed to explore new materials combinations and particularly look at the interfaces between those 2 materials to really control the interfaces and seeing the design of next generation or next but one generation devices. On the right-hand side, there's an ion beam system at the University of Manchester called PNAME, which is for deterministic single ion implantation, and it was co-designed with Ionoptica, the company that make it. And so these are 2 examples of Royce facilities that are accessible to allow that next generation of devices to be made. And if you want to access Royce facilities, there's a QR code at the bottom which may, if you're lucky, take you to the Royce page, which will allow you to look at that. Just picking up on that PNAME activity, the ion activity in Manchester, let me just give you one result. So this is about isotopic purification of silicon, and you might think, why would you want to do that? But it turns out to be rather important for quantum computing applications that you have isotopically pure silicon. And the colleagues at Manchester have now shown the ability to get the world's purest isotopically pure silicon, which will have is likely to have a significant impact on quantum computation. Advantage of this is not only can they purify it with their ion beam system, they can also selectively implant it with the impurities you will need. So this just gives you a flavour of some of the facilities that Royce has funded. So the next part of this is about catalysing industrial collaboration, exploitation of materials research, or in semiconductor strategy, support the sector through the technology cycle, fostering a new culture of enterprise, quite similar wording. So a couple of examples here. We have a clean room facility at Leeds. It's a research facility with lots of access for lots of different projects. And the idea of this facility is to do fundamental research across things from semiconductors to spintronic devices to microfluidic devices. But it also is a great test bed for industry to come and do some early stage prototyping. And we do have industry coming in to do some integration of non-standard materials, some early parts of their process cycle. A really important thing that I want to stress is the bottom line. It's supported by highly skilled research technical professionals, and this is what makes it really work, both from a research perspective, but also for bringing industry in and actually be able to help deliver things for them. And I think it's really important that we just need to keep that in mind, that we need to find funding, career paths, and everything else for these RTP community that are actually going to deliver on these facilities. And I think that's a mistake we've perhaps made in the past, is not supporting them as much as we should. Okay, again, if you want to see what we're actually doing in Leeds, there's a QR code for that. A latest thing that has happened is very recently, the Royce has been working with the University of Swansea and the Centre for Integrated Semi-Materials, which we've heard about earlier on today. And so there's a new instrument going for wafer scale inspection, which is jointly funded by the Wolfson Foundation, the Royce Institute, and also Welsh Government. I think it says late 2024. I think it's probably September 2024 will be arriving. And again, there will be access to that instrument through the Royce, so that actually if you want to try something, it is possible to do that. So again, this is sort of trying to catalyse things going from research to industry and that connection between them, and that's one of the things that Royce is trying to do. And then the last bit is about fostering material science skills development, innovation, training and outreach, the Royce statement, and the right-hand side you've got the National Semiconductor Statement, which is attract the skilled talent it needs and train tomorrow's semiconductor innovators. So we've been trying to do a little bit of that. And so a few things have happened. The top line is we've established, it's now run for 2 years, a national training school in practical cleanroom skills. This is a collaboration between Leeds, CISM in Swansea, and the new Cavendish cleanroom in Cambridge. And the RTP teams from those 3 sites have come together to deliver what is make, with no previous experience, a transistor in a week and test it. And we've run it now for 2 years. It's in Swansea next January. And we've taken 20 people and gone through and made a transistor, tested it, and they've all got their transistors working, which has been quite a triumph. Interestingly, we set this up, we thought it would be first-year PhD students wanting to do this. Not a bit of it. Well, they have done. We've got final-year PhD students who haven't been in a clean room and want to know what a clean room is about. We've had people from industry wanting to come and actually see what it is to work in a clean room, doing a different job in industry. We've had people who are doing theoretical modelling who say they want to understand what a clean room process is like to feed in their modelling. So it's become extremely successful, and it's been led by those research technical professionals. So again, a big shout out for them. This is something that we'd really like to expand and do more of, and my call is we could do more of it quite easily, but it's quite intensive on people. That's 4 people for 20 to teach 20 people in a week. If you want to do more of it, we need to have more RTP people, technicians, to help do that. But we could do that easily with more people to support that. In addition, we've been doing outreach programs from school. On the right-hand side, there's some students from Roundhay School, which you'll all recognise as being the school that Liz Truss had a few comments to make about it. So we thought we ought to help there. So we brought some students from Roundhay School. We got them into the clean room. We had the school crest. They looked on an electron microscope. They spun some resist. They exposed some resist. They really enjoyed it. We've done that. We've also had some work experience students into the clean room getting there. Really great for those students. They've loved it. They've really been enthused by the semiconductor industry. We need to scale that up, I think, to make a real difference. So I think that concludes what I wanted to say, and I think I've managed to keep you a couple more minutes back of time, Charles. So Royce Adams' nice thing, I think, is contributing to the semiconductor, or trying to contribute to the semiconductor strategy, providing advocacy, supporting translation, developing skills. Really want new collaborations. I've given you a couple of contact details above, at the right-hand side. But please, can I ask, if you don't know about the Royce Institute, please sign up to it. There's lots of activities going, which is both for academia, but also supporting the translation. And it would really be useful if the body of people in this room could connect into Royce, because I think there are opportunities throughout National Institute to look at the materials we will need for the future and work with industry to actually make those materials relevant to what future industry will need. And with that, I will stop and give you 5 minutes back, Charles.